Assalamualaikum and good day everyone. We are from Group 3 and today we will present about the Suzuki Latex Industry Malaysia Company where we will talk about the background of the company, the products they produce and also the process and also occupational health and safety in the company. So before we started, let me introduce myself. My name is Muhammad Adam bin Razali and the other team member is Muhammad Idham Hilmi bin Huzali, Hanisa and also Primila. Next, we will talk about the background of the company. The Suzuki Latex Industry Malaysia is a manufacturer company of high-grade natural rubber latex products, catering to global high-tech industries to facilitate in the advancement in polymer processing while leveraging regional proximity advantage for raw material. It was established on July 18, 1987 as a key subsidiary of Suzuki Latex Industries Corporation at Japan and has quickly risen to prominence as a leading global supplier of engineering components for technical markets. Next is the product portfolio. It's specialized and advanced as they offer wide range of cleanroom grade products, including specialized cleanroom finger coats, ultra clean finger coats, powder-free finger coats, anti-static ESD finger coats, and so on. Next is the market reach. They supplies over 50% of the Japanese technology workforce with a critical electrical components, while simultaneously exporting to high-tech aerospace, microelectronic, and semiconductor sector throughout Asia Pacific, Europe, and North America. Next is evolution include transitioning manufacturing priority from consumer focus, rubber novelties like the handcrafted peacock balloon in the late 1980s, automating and scaling dipping lines to fulfill massive supply gaps in global technical markets. Next, Suzuki Latex Industry Malaysia Sdn Berhad is located at Lot 14, 26 Jalan Api-Api, 2601, Section 26, Kawasan Perindustrian Haikom, 40400 Shah Alam, Selangor, Malaysia. Next, let's move to the products. There are various types of finger coats that produced by the Suzuki Latex Industry Malaysia, such as Sport Pink as chlorinated, Mass Orange, and also Shield.
Hi everyone, my name is Nur Hanisa Mijal Zulkifli. My metric number is TN25071. Now I will continue by explaining the objective of our online industrial visit before moving on to the major equipment in the finger coat manufacturing process. The first objective is to have an exposure to real industry environment. This means we are able to observe the actual manufacturing process and understand how engineering concepts are applied in the real factory instead of learning in the classroom. The second objective is to know the process flow diagram or PFD and explain the overall production process. The PFD helps us understand the sequence of the production beginning with the raw latex storage continue until the finger coat's final production. The third objective to analyze the major equipment used in the finger coat manufacturing process. We study the function of each equipment and how every unit contributes to the producing high quality finger coat efficiently. The fourth objective is to discover occupational safety and health or OSH practices implemented within the company. This allows us to understand how the company protect workers through safety procedure, personal protective equipment and proper workplace management. Finally, the objective is to identify the operational issue and propose suitable engineering solution based on mass and energy balance principle. This helps us to improve production efficiency while reducing downtime and material losses. Now I'll move on to the discussion of the major equipment. The first equipment is the raw latex storage tank. As shown on the slide, the function is to store natural rubber latex before production. The latex is imported from Thailand and kept in this tank before entering the production line. The second function is to act as a buffer storage to ensure the continuous supply of raw material. This means that even if a delay in the raw latex delivery, production can continue without interruption. Next, it's important to protect latex from contaminant. This is important because finger coats are used in medical and pharmaceutical industries, so the latex must remain clean and free from dust or microorganisms. Finally, the instrumentation include level indicator which monitor the amount of latex inside the tank and temperature indicator which ensure the latex is stored in the correct temperature to prevent deterioration. Next is latex blending tanks. Its function to make raw latex with ammonia, stabilizer and other additive. Ammonia helps to prevent premature coagulant while the additive improve the elasticity and durability of the finger coat. The second function is to produce a homogeneous latex compound. This means all the chemicals are evenly mixed, so every finger coat has consists of the quality and the thickness. It include the four key parameters, which is pH, temperature, viscosity, and agitator speeds. pH is controlled to maintain the latex stability. Temperature prevents the latex from degrading. Viscosity affects the coating thickness during dipping, and agitator speeds ensure all the additives are mixed uniformly. The instrumentation consists of a pH meter, temperature indicator, and agitator speed controller, which continuously monitor these operating conditions. The third equipment is the dipping machine, which is the main production equipment. The first function is to form finger coats by dipping ceramic former into the latex compound. When the ceramic former are immersed in the latex, a thin layer of latex sticks to the surface. The second function is to determine the initial shape, thickness, and uniformity of the product. Therefore, this stage has a significant influence on the final product quality. Under process control, the thickness depends on the dipping time, latex viscosity, withdrawal speed, and temperature. For example, a longer dipping time usually produces a thicker finger coat, while higher latex viscosity also increases the coating thickness. The machine is monitored using a speed controller, timer, temperature indicator to ensure stable operating conditions. The next equipment is the beading unit. The first function is to form a thickened bead at the opening of the finger coat. This bead strengthens the opening of the product. The second function is to prevent tearing by the redistributing mechanical stress during donning. In other words, it makes the finger coat more durable when users stretch in during wearing. The third function is to provide a grip handle for the downstream stripping machinery, allowing the removal unit to remove the finger coat easily from the proceeding former. Under process control, bead quality depends on the roller friction, track alignment, and brush rotation, while the latex must remain in a semi-solid state during this process. The instrumentation includes motorized rollers or nylon brushes, adjustable tracks, and conveyor speed controllers. The next equipment is the removal unit. Its function to break adhesion between the cured finger coat and the porcelain former. The second function is to peel the product without stretching it beyond its elastic limits, ensuring the finger coat is not damaged during the removal. Lastly is detach the finger coat from the mold into individual wet coats before sending them into the next process. Under process control, this removal achieved using a synchronized pneumatic air blast and mechanical rolling action. The compressed air creates a small air cushion that separates the finger coat from the mold, while the rollers gently peel it off. The instrumentation consists of pneumatic air injection manifold, counter-rotating stripping roller, and gravity discharge hoppers. Now let's see how chlorination tank works. Its function to carry out the surface modification on the strip wet finger coats. The second function is to micro-harden the rubber surface, changing it from a sticky surface into a smooth satin-like finish. The third function is to lower surface friction, eliminating the need for powder and making the finger coat suitable for cleanroom and pharmaceutical application. Under process control, chemical exposure is maintained by continuous fluid recirculation. The chlorine solution is prepared automatically using sodium hypochlorite and hydrochloric acid, producing the hypochlorous acid which react with the rubber surface. The instrumentation include a chemically inert vessel, high torque overhead impeller, and an automatic chemical dosing system to ensure the chlorination process operates safely and consistently.
The next equipment is finishing dryer. So the function is to remove moisture to prevent microbes and water spots, drive post-cure final polymer cross-linking, and also optimize strength, elongation, and elastic recovery. Next is to the process control. Is uniform tumbling via internal flights preventing clumping. PLC control zones regulate temperature from 60 degrees to 90 degrees. Instrumentation consists of rotary drum dryer or tunnel furnace, programmable logic controller PLC, lifting flights or bevel systems. Next, we move to the rolling unit, the next equipment. So the function is to shape dry coats into a compact standard rollaging. configuration, prevent tangling, static clinging, or collapsing during bulk shipping, ensure smooth flow through downstream QC inspection and high-speed packaging. Next is the process control. It rolls piece tightly via linear shear force from belt velocity differentials. Uncoils and aligns coils using vibrating plates before entering the belt gap. Guide deformation from the beaded rim down to the closer tip. Next is the instrumentation. There's a multi-tiered moving belts, vibrating sorting plates, and also a friction baking pads. Next is a selection conveyor. The function is to facilitate visual inspection of fully formed, dried, and stripped finger coats, enables manual removal of defective pieces displaying surface flows, micro tears, or uneven edges. Next, to the process control, is maximize visual contrast via a bright white belt color against the rubber piece. Eliminate shadows and blind spots using long, high-intensity overhead LED arrays. Regulate transport speed to allow operators seated along the deck to uniformly spot defects. Next is instrumentation. Wide flat conveyor bed with a wide PVC or polyethylene valve, variable frequency drive motor, overhead LED lights arrays. Next, quality control station. The function is to enforce international standards using sample lot physical testing. Flex invisible pinholes by filling coats with water over electronic moisture sensors. Measure mechanical threshold for exact tensile strength and bursting pressure via air inflation. Verify surface resistivity limits through electronic discharge ESD testing. Next is to the process control. Automates batch handling by clamping samples onto pneumatic expansion nozzles. Triggers instant alerts using electronic detection choice to catch leaks. Differentiates testing criteria by adding ESD verification specifically for cleanroom or electronic grade codes. Next, the instrumentation, multi-head physical testing, manifold, water leak tester, and air inflation tester, pneumatic expansion, nozzle and electronic sensor detection trays, and ESD testing hardware. Next is a packing line. The function is to package finished coats while maintaining cleanroom standards, counts out precise commercial batches, prevent degradation and oxidation during storage. Next is the process control. Feeds code single file using a vibrating system past a counting sensor. Displays oxygen by instantly flushing pouch with the inert nitrogen gas. Hermetically seals the packaging using heat and automated boxing. Next is the instrumentation. Vibrating ball feeder and optical laser sensor, pneumatic nitrogen nozzle, also heated mechanical jaws and automatic carton sealer. Lastly, we move to the storage tank. The function is to store and mature raw liquid latex emulsion, stabilize the colloidal suspension to prevent premature clotting, homogenize additive mixes including vulcanizing agent, accelerators, and stabilizers. Next is process control. Regulate temperature between 20 degrees Celsius and 25 degrees Celsius via chilled water outer jacket circulation. It prevents friction coagulation by utilizing low shear mixing instead of high-speed blades. It ensures uniform composition by introducing chemical agents through the overhead feeding parts. Lastly, the instrumentation. A vertical double-jacket stainless steel vessel, top-mounted low RPM electric motor, large sweeping anchor or pedal-style impeller, overhead feeding parts.
Now, we will explore the key OSH practices implemented in the industry and their importance in maintaining a safe workplace. This presentation will focus on the OSH practices implemented at Suzuki Latex Malaysia and how the company promotes a strong culture of workplace safety and health. First is regular hazard identification and risk assessment activities. Second, continuous employee safety education and training programs. Third, monitoring of workplace conditions to reduce occupational risk. Fourth, day compliance with safety regulations and company safety procedures. 5. Day promotion of a safety culture through SHE committee activities. And lastly, they focus on accident prevention and continuous improvement of workplace safety. Now, I will talk about the occupational safety and health applied in this industry. The company demonstrates a strong commitment to occupational safety and health through the implementation of safety policies. First, committed to ensuring the safety, health, and welfare of all employees during working hours. Second, protects employees from occupational injuries and workplace hazard. Third, supports a dedicated health and environment committee. Fourth, conduct regular safety, health, and environmental patrols to identify risks. Fifth, implements 5S housekeeping practices to maintain a safe workplace, which is sort, set in order, shine, standardize, and sustain. Lastly, provides safety training, seminars, and awareness program for employees.
Based on the interview with the HR representative from Suzuki Latex, one of the main challenges faced by the company is the limited shelf life of its latex product, such as finger cords and balloons. According to the interview, these products can only be stored for approximately 3 to 6 months after production because the quality of rubber will gradually deteriorate over time. Therefore, the company does not produce product in large quantities. Instead, production is mainly carried out after receiving customers' orders to avoid unnecessary wastage and storage costs. To address this issue, the company can continue implementing a make to order production strategy while improving demand forecasting and inventory planning. Better storage conditions such as proper temperature and humidity control can also help preserve products' quality. The second issue identified is machine breakdown during the production process. The HR representative explained that there have been cases where a machine stopped operating after all the raw materials had already been mixed into the system. When this happens, the materials cannot be recovered or reused, resulting in significant material wastage and financial loss. In addition, production delays may affect the company's ability to fulfill customers' orders on time. A suitable solution is to strengthen preventive maintenance by conducting regular inspections and servicing of the machines. The company could also implement machines monitoring system to detect early signs of failure before a major breakdown occurs. The final challenge is the use of aging and customized machinery. Most of the production machines at Suzuki Latex are more than 30 years old and were specially customized for the company's manufacturing process. While these machines are still operational, their age increases the risk of breakdowns and obtaining replacement parts can be also difficult because the machines are customized. To overcome this issue, the company should gradually replace or upgrade the older machines in phases. This approach allows the company to modernize its equipment without placing excessive financial pressure on the business. Proper documentation of the machines and collaboration with engineering specialists can also improve maintenance efficiency.
And now, we are at the end of this presentation and going through our conclusion. This project provided a valuable industrial insight into the latex manufacturing sector of chemical engineering technology for Suzuki Latex Malaysia SDN BHD and highlighted the importance of integrating engineering principles, workplace safety practices, and effective operational management to achieve sustainable industrial performance. We hope this presentation will acknowledge people to get to know more about chemical engineering in our daily life and in our industrial country. Thank you.